Have you ever wondered what the most powerful questions are? I don't just mean in philosophy, but in computer science. Well, today, we're going to explore a type of logic that operates right on the very edge of what's even possible to compute. It's called QCTL star, and it's the logic that takes the question, what if, to a whole new level.
To really get our heads around this, let's start with an analogy. Think about your GPS. It's great, right? It helps you navigate the streets that already exist. But the logic we're talking about today is like a GPS that can look at the map and say, you know what, let's just build a new bridge right here. It's not about finding routes, it's about redesigning the map itself to make better routes possible. That's the scale of thinking we're about to dive into.
Okay, so before we can start redesigning the whole city, we've got to learn how to read the map. So we need to start with the basics of something called temporal logic, which is really just a fancy way of talking about logic that deals with time and all the different possibilities that can unfold.
And this breaks down the first couple of steps perfectly. So on the left, you've got CTL. Think of this as your standard GPS. It answers a really simple question. Can I get there from here? It's all about reachability. But then on the right, we level up to CTL star. This is way more advanced. It handles complex questions about the entire journey. It's asking, can I get there by taking a specific kind of route? Like a scenic one that avoids all the highways. You see the difference? It's reasoning about the whole path, not just the destination.
So if CTL is about reachability and CTL star is about specific paths, what could possibly be next? Well, this is where our main topic, QCTL star, finally enters the picture. And let me tell you, this is a monumental leap in power.
The secret sauce that gives QCTL star all its power is something called propositional quantification. Now, I know that sounds super technical, but stick with me. A proposition is just a statement that's either true or false, like, this road is open. The quantification part is where the magic is. It means we can ask questions about those statements. So going back to our GPS, this is the power to ask, what if we could add a new bridge right here? Or what if we could just close this road to make things better? It's not just about the map as it is, it's about asking if a better map could even exist. You're questioning the very rules of the system, not just playing within them.
This really lays out the whole progression beautifully. With CTL, you're asking, can I get there? With CTL star, you're asking, is there a scenic route? But with QCTL star, you ask the ultimate meta question. Could we actually change the map itself to guarantee that all possible routes are scenic from now on? That is just a huge jump in abstraction.
Just how powerful is this stuff? Well, QCTL star is in the same league as what's known as monatic second-order logic, or MSO. And for anyone in the know, MSO is basically the heavyweight champion of expressive logic. Being compared to MSO means QCTL star can state incredibly nuanced and complex properties about a system. The key takeaway here is, we're dealing with some serious logical firepower. But, as you probably guessed, this kind of unbelievable power doesn't come for free. In fact, it comes with a pretty profound and, well, dangerous cost. On the one hand, you get maximum expressivity. With QCTL star, you can formulate questions about computer systems that are just unbelievably detailed. You can check for these really subtle properties related to security, or fairness, or robustness.
And on the other hand, you get this. For many of the incredibly powerful questions you can ask with QCTL star, it is mathematically proven to be impossible to compute an answer. Not just hard, not just slow, literally impossible. The logic is so expressive that it can formulate problems that are just beyond the grasp of any computer that could ever exist.
To put a name on this level of complexity, some of these problems are what we call tower complete. Now, this isn't just exponential growth, which is already incredibly fast. Tower complete means the resources you need, like time or memory, grow at what's called a non-elementary rate. It's like a stack of exponents. It's a number so vast, it's difficult for our brains to even comprehend, making these problems completely and utterly unsolvable in practice. This table really clarifies where all that complexity comes from. If you look at the top row, if you're asking a QCTL question just about the system's basic structure, our GPS map, the problem is hard for sure, but it's in a known complexity class. But as you move down, the moment you start asking questions about the infinite tree of all possible futures, that's when the complexity just explodes. First, it jumps to an exponential level, and then for certain types of problems, it goes all the way up to that tower complete level of impossibility. It all depends on how deep your what-if question really goes.
So this leads us to a fascinating final point. If this logic can create questions that we literally can't answer, then what's the point? Why would anyone even develop something like this?
And this is why it all matters.
Logics like QCTL star are tools for exploring the very limits of computation. They give us a language to formally and precisely define incredibly complex ideas like fairness or security, even if we can't always check for them automatically. And that theoretical foundation is absolutely crucial for verifying our most critical systems. Plus, the sheer challenge of it all inspires computer scientists to find clever new ways to solve smaller, practical pieces of these massive problems. It's really about drawing the map of what is knowable and what isn't.
So we're left with this thought. QCTL star shows us that sometimes the most important contribution isn't finding an answer, but learning how to formulate the perfect question. It pushes us to think about problems in totally new ways, even if the final answer remains just out of reach. It really makes you wonder, when a problem is too complex to be answered, does the question itself still have value?